This lesson will teach you the third and fourth index laws, and then it'll give a few examples at the end of applying all the four index laws together in the same equations to simplify these expressions. The third index law relates to raising a power to a power. So you can see that in this expression, we have b squared, or b to the power of 2, and that's all being raised outside the bracket to the power of 3. So let's go and let's unpack this, and I'll try and draw out this equation so it makes a bit more sense. So essentially what we're doing is b squared all to the power of 3. So we are essentially going b squared times by b squared times by b squared. So as you can see, that is b squared to the power of 3. We know that b squared is b times b. So all of those are b times b. And we're multiplying those all together, you can see. So I'll just go and put some brackets back again so you can see those separated. Now we know with the first index law that when we are multiplying bases or indices together, that we add the index. So you can see in this case, it's sort of relates to the first index law with some multiplication. You see that you have 1, 2, 3, 4, 5, 6. So b is being multiplied by itself 6 times. So therefore we can see that the answer is going to be b to the power of 6. Put more simply, you can see if you go back to the question of b squared all to the power of 3, that you might notice that in this case we have actually multiplied the powers together. So quite simply, the shorter way of doing it, and the third index law, is that when we raise a power to a power, we multiply the indices together. So we can do it like this. b 2 times 3, which will give you b to the power of 6. So that is the shorter way to do it, but the first part just gives you a little bit of an understanding as to why when we're multiplying them together. The final index law, and probably the easiest one, is that anything to the power of 0 is equal to 1. So you can see a to the power of 0 is equal to 1. You could say 52 to the power of 0 is equal to 1. You could have a crazy equation in brackets like 321 times by a squared all to the power of 0. Doesn't matter, it's inside the brackets, all getting raised to that power of 0. It's going to be equal to 1. To explain this a bit more simply, for example, if you had 2 to the power of 3 divided by 2 to the power of 3, if you use your second index law to subtract the powers, you would end up with 2 to the power of 0. So if I did this a long way and actually had 2 to the power of 3 written out like that, and 2 to the power of 3 written out like that, you can see that that equation is actually equal to 8 divided by 8, which is equal to 1. So pretty easy, pretty simple. Anything you see, if you see to the power of 0, you know it is equal to 1, no matter how complex, even if it's crazy, something like this in brackets. If it's raised to a power of 0, it will be equal to 1. Let's now have a go at trying to solve some equations that involve a few different steps. So let's look at this equation. The first thing I'm going to do with this equation is I'm going to tackle each line and try and simplify and combine the things on each line first. So if I look at the first one, I'm going to do the numbers at the front, which is called the coefficients, first. They're both the same. They're base, both numbers, so you can combine them. So 25 times 8 is equal to 200. You can see that V and W, in this case, they aren't the same base, so you can't combine them. So v stays to the power of 6 and w stays to the power of 9. Same thing down the bottom, 10 times 4, same base, numbers and numbers, we can multiply them together, which is equal to 40. V and W stay the same, we can't combine them, they don't have the same base. Now we can think about using our knowledge of the index laws to simplify this equation. I like to think of it like simplifying a fraction. So firstly, let's deal with the coefficient out the front, the numbers, and I'm going to try and simplify this into the easiest form of fraction. So I'm actually going to divide both of them by 40. I can see that's the highest common factor straight away. So divide that by 40 is 1, divide that by 40 is 5. So in this case, the next step for me to do is to then, same thing, substitute, or in this case, sorry, is to then use the second index law, dividing, same base, so we can subtract the powers. So in this case, we can go and write the equation something like this. 5 of V6 take 4 and W9 take 5, which is going to be equal to, technically that is all over 1 as well. You can see that that's the 1 on the bottom of the fraction, but we know dividing by 1 is going to keep things the same. So the answer is going to be equal to 5 V2 W to the power of 4. In this case, in this line, you could have done a slightly different step, and you actually could have just done in this case, and sometimes I like to find this way is quicker. And 9 take away 5 in this case is 4, so we can just cancel out the 1 on the bottom. 6 take away 4 is 2, so we can cancel out the 1 on the bottom. We would have been left with 5 V to the power of 2 W to the power of 4 all over 1, which would then get us to the same answer that we had before. Let's try this next equation, which is slightly different. So same theory, I'm going to start with the numbers on the top line first. Same base, they're both numbers, so we can multiply them together. 7 times 4 is 28. In this case, you can see that t to the power of 3 and t to the power of 8 is the same base. So then we can use the first index law and we can add the powers together. So that is going to be equal to, and I'll do this quick because I don't have much room, 3 plus 8 is going to be equal to t to the power of 11. For the first step, the bottom line is going to stay the same. Then we can simplify the same as we did in the previous equation to work out the next row. So I like to think of it as simplifying a fraction and look for the highest common factor that I can divide both of the numbers by. So I like tackling the numbers first. So what can I divide both these by? Highest common factor that I can divide them both by is 4. So 12 divided by 4 is 3. And 28 divided by 4 is 7. So our equation is going to start looking like this. In this case, whichever way you want to work this, you could do what we did before, but you can see that we've both got t's, second index law, dividing. So we're going to subtract the powers. So you could go t11 take away 4, or you could simply go and do the rule or the quick step, depending on which you think is easier. You could cancel out the bottom one and take 4 away from the top line. Regardless, we're left with 7t to the power of 11 take away 4, which is going to give us 7t to the power of 7, and that is all over or divided by 3. So that is the simplest form of this expression. Okay, here is our final example. and probably as hard as we need to get with the index laws for now. So this one you can see has raising a power to a power. So it has the trickiest index law involved. So the key with this one is to know that also numbers actually have a power to them as well. So if we expand this equation, numbers, so there's a 2 there and it's 5, they're actually technically always to the power of 1. So they actually have a power there. So sometimes when we do these equations, we can miss knowing that the coefficient or the number in front of the letter actually has a power. So when we're raising to a power in a second, we've got to remember that. So let's try and expand it by raising the first brackets all to the power of 2. So let's do that in red. So that's going to be equal to 2. You can see that 2 is to the power of 1, so it's going to be 1 times by 2, using that index law of raising a power to a power. And then it is going to be b 5 times 2. And that's all going to be multiplied by, on the other side, 5, which is to the power of 1, as we know, times 3, b to the power of 8 times 3. So if you write that out more simply, the next line is going to be equal to 2 squared, or the power of 2, b to the power of 5 times 2, which is equal to 10, times by 5 to the power of 3, b to the power of 8 times 3, which is equal to 24. Okay. Now to simplify this even further, we're actually going to simplify these numbers so that they are no longer in index form. So we know that 2 to the power of 2 is 2 squared, which is 4. So then we'll leave b10 the same for now. And 5 cubed, or 5 to the power of 3, is 5 times 5 times 5. So 5 times 5 is 25, times another 5 is 125. b to the power of 24. So the next step and the final step in this one is then to get our things that have the same base and combine them. So you can see that the numbers, same base, they're both numbers, we can combine them. So 4 times by 125 is equal to 500. And in this case, our first index law comes in with the b's. B, B, same base. We can add the indices when we're multiplying. So it's going to be b to the power of 10 plus 24. Sorry, that 10 looks like a 16. Definitely 10. Which we know is then going to be equal to 500 b to the power of 34. I guess the most important thing to remember with these ones is that when we come across a number like 2 or 5, when we're using that index law and raising a power to a power, that we need to remember that a number always is to the power of 1. So we need to always raise the number as well to the power outside the bracket, not just the pronumerals or the letters or the algebraic things inside the brackets.